All right, here is part 2 of the 4.2 lesson. Quickly, just two types of special triangles. You've heard of these before, but we're going to start with the 45 triangle. All right. So I've got. I'm going to sketch one real quick. There you go. It's a 45-45 triangle, and I'll call it C, A, and B again. This time I'm trying to hold the mic closer to my mouth. It sounds like the audio in the front is a little quiet. Still not sure how to fix that, but hopefully this one's better. It's kind of good volume. No, it's all the way up. So we're saying if this is 45 degrees and this is 45 degrees, these sides have some fairly properties. All right, so to get started, let's just make this side 1. It's just 1. It means that this side is also going to be 1, and then the hypotenuse is going to be the length of one of the short sides times square. That's always the case. So if side AC happened to be 4, then the hypotenuse would be 4 times. All right, but the ratios are always the same. So if I said what's cosine 45 degrees? Okay. So cosine of 45 degrees, because they're both 45 degrees, it doesn't matter which one I use as my reference angle. I'll just pick this reference angle. So cosine is the adjacent side, which is 1, over the hypotenuse, which is square root of 2. All right. Hopefully you remember, but we do not like square roots in the bottom of fractions. So we have to do what's called rationalizing the denominator. All that means is we want to get the square root out of the bottom of the fraction. We're going to do that by multiplying the top and the bottom by square root of 2. 1 times 2 square root of 2 on the top. The bottom, when we multiply square root of 2 times itself, we just get 2. All right? So there's cosine of 45 degrees. If I say, what's tangent of 45 degrees? Tangent is, let's use the same reference angle, opposite over 1 over 1, which is 1. That was easy. All right, what else might happen is you might see your angles and radians. All right, it doesn't always be in degrees. All right, so sine of pi over 4. All right, a couple ways to think about this. The first way is just to remember that pi over 4 is 45 degrees. First, the most easiest, straightforward way to do this. But if you don't remember what pi over 4 is equal to, we can convert this back to degrees by multiplying 180 over pi. The pi's cancel out. 180 divided by 4 is 45 degrees. So this is the same sine. This is the same as sine of 45 degrees. Let's see, same reference angle. Sine again is 1 over square root of 2. Well, I didn't write that correctly. Yeah, it's 45 degrees. Sine of 45 degrees is 1 over square root of 2. And if I convert that, or if I rationalize that, if I rationalize the fraction there, I can get this. So sine of 45 degrees is the same as cosine of 45 degrees. Then you might be given your angle radius instead of degrees. All right. So the other special triangle is called the 30-60 triangle. The angles are 30 and 60. That kind of looks like one. All right. So let's say this one is 60 and this one's 30. And this is the 30-60 triangle. There. We'll say C, B. All right. So a couple examples. You might see, ratios. All right, let's make this one length 1. All right, if this is length 1, the hypotenuse is always double it. All right, and then leg is the shortest leg, which is 1 times the square root of 3. There are the ratios. Okay, so if I say what's tangent of 30 degrees? tangent of 30 degrees, so here's my reference angle here. It has to be this one. Tangent of 30 degrees is going to be 1 over square root of 3. So that was the opposite side divided by the adjacent side. And rationalize this denominator. Multiply the top and the bottom by square root of 3, square root of 3 over 3. Alright? One as radians. You might see pi over 6. You're writing, oh, I wonder what pi over 6 is. Well, you can remember it, or you can convert it to degrees, which is 30 degrees. Because 180 divided by 6 is 30 degrees. So this is the same as tangent of 30 degrees, which would be the same thing as we just did. One more example. Let's do like cosine of pi over 3. Okay, pi over 3, if we convert it, is the same as cosine of 60 degrees. So if we're doing cosine of 60 degrees, we have to use 60 as a reference angle. And adjacent is a 1. Hypotenuse 2. 1 over 2. That one works. All right. I feel like that's good enough for the special right triangles. Yeah. All right.